So when I'm looking for a horizontal asymptote, what I want to attend to is the highest power that appears in the top and bottom. I can see that both of these have a quadratic in the top and bottom. And so since they're the same powers, same highest power, the asymptote is y equals, and you're going to look at this, the coefficients in front of the x squared. So that's the 3 over 1. So you're going to do coefficient of the highest power on the top over the coefficient of the highest power on the bottom. So in this case, it's y equals 3 over 1. For the next one, I can see that this is linear on top, x to the first, and this is x squared here. And so the power is higher on the bottom. Highest power of x is on the bottom. And what that means is that our vertical asymptote is going to be y equals 0. Okay. And then if the highest power on top is greater, then there's no horizontal asymptote. In fact, we'll have something that's called a slant asymptote. But I think you don't need to compute it because, well, if you divide a cubic by a linear, you'll get something quadratic, and so you haven't really made sense of that yet. So we'll just say no horizontal asymptote for now on that one. For the next one, it says to actually find the slant asymptote. So what I'm going to do is I'm just going to do the division, and that remainder is going to be my slant asymptote. So if I do this long division, I'll just do x cubed plus 3x squared minus 2x minus 4. And since that's missing the linear term in the bottom, I'm going to write x squared plus 0x minus 7 so that we don't get ourselves confused with the lining things up. Okay, and so I'm going to multiply x by each of those. So I'll get x cubed plus 0x squared minus 7x. And when I subtract that, I'm going to get negative 3x squared minus 0x is just 3x squared. And then negative 2x plus 7x is going to be plus 5x minus 4. And so then I can multiply by 3. So I'll get 3x squared plus 0x minus 21. And I want to subtract all of that. And so the 3x squared goes away. 5x minus 0x is just 5x. Negative 4 plus 21 is going to be 17. So positive 17. Okay, and so so what we're going to get there is that this f of x is equal to this x plus 3 here plus 5x plus 17 over that thing, x squared minus 7. And so what's going to happen is as x gets bigger and bigger, this part's going to go away. And so what we're going to end up with is that our slant asymptote is just going to be x plus 3 is y equals x plus 3. So it's not the remainder, it's the quotient that you get. So I misspoke earlier. Then it says graph the rational function, and so we're given that. So what I'm going to do is first I'm just going to factor it all out, the top and bottom, so we can kind of see what's going on there. And I can see that the top factors to, let's see, well, I can factor the bottom pretty easily. It's x plus 3x minus 3. And then on top, we're going to get x 4 and 2. So I want the 4 to be negative and the 2 positive to give me what I want. Okay, so there is my function there. So my vertical asymptotes are going to come from the denominator here. So I'm going to get x equals 3 and x equals negative 3. I don't have any slant asymptotes, but I do have a horizontal asymptote. If I look at the power on top and bottom, it's the same. So I'm going to look at those coefficients. So my horizontal asymptote is going to be y equals 1 over 1, which is 1. My y-intercept, that's what I get when I plug in 0 for x. So if I plug in 0 for x, I'm going to get negative 8 on top and negative 9 on bottom. So it'll be 8/9. And then my x-intercepts, I can figure those out by looking at the numerator here. So my x-intercepts are going to happen when x equals 4 and when x equals negative 2. Because if I plug in 4, I'm going to get 0 on top. If I plug in negative 2, I'm going to get 0 on top. So those are my x-intercepts. And then where the graph crosses the horizontal asymptote, if applicable. So let's do that in a second. So let's go ahead and plot what we have here. So I've got 3 as one of those, and negative 3 is here. And then y equals 1 is a horizontal asymptote. I'll plot that here. And then my y-intercept is 8/9, which is pretty darn close to 1. Okay, and then so it's going to go like that. And so as so let's plug in some other points. So if we have x squared minus 2x minus 8 divided by x squared minus 9. Okay, and so if I plug in numbers, some different numbers, so let's do let's plug in like 2, and I get 1.6. So that's here, 2, 1.6. And if I plug in like negative 2, I get 0. Oh yeah, I knew that already because that was one of my zeros. I also have that 4 is a 0. Okay, and so it looks like I can start to kind of graph. It's going to go like that to that asymptote. Oops, it's going to go like that to that asymptote. Oh, that looks kind of bad. Let's see if I can fix that. And then we've got this going here and here, and then we're not quite sure what's happening on the other side of 3, so let's plug in negative 4 and see what we get. We got 2.28. Okay, so if we plug in negative 4, then we get 2.28, so it's going to be doing something like this. I didn't find the spot where it crosses, so let's go ahead and do that. So I want to say 1 is equal to x squared minus 2x minus 8 over x squared minus 9. So I can multiply that over. I get x squared minus 9 is equal to x squared minus 2x minus 8. I can see that I want to move everything over to one side, so I can subtract the x squared off, and so those are going to go away. And then I can add that 9 over, and I get or I can add that 8 over, and I get -1 equals -2x. And then I can divide by the -2, I get x equals 1/2. And so that's where it's going to cross that axis. So it's going to be at 1/2, 1. That's where that crosses there. And I think that's it. So the next one says write a variation model for the situation. So the volume of a rectangular solid varies jointly with the length and width of the solid. And so I can say V equals K times L times W. The simple interest varies directly with the amount of the loan. So I can say I equals KA. And then the cost is inversely proportional to the number of miles. So I can say C equals K times 1 over M. The yield on a bond varies inversely as the price. So I can say that yield, I'm going to call that Y, and the price, I'm going to call P. So I can say yield equals KP. The yield on a particular bond is 5% when the price is $120. So we'll put in a 5 for the yield, and we'll put 120 for P. And I can divide that over. And I get K equals 1/24 when I simplify that. And so now I know what my K is. And so now I want to find when the yield when the price is 100. So I can say Y equals, I know what my K is, I'm going to plug that in, 1/24, and then the price is 100. And so the yield on that is 4.166%. And so that's my answer.